So we're going to start chapter 7. How many of you have ever heard of logarithms? Okay. So this unit is probably the first time some of you have ever seen logarithms. So you guys, when you do your homework, you're going to have to make sure that you're checking it and that you understand it, okay? Because this is probably like first time, probably really new stuff. Okay. So we're going to talk about exponential functions today, which leads into logarithmic functions. The reason that they're called exponential functions is because the x, the variable x, is the exponent. Usually we have like x squared, x to the fourth, x to the third, or just plain x. This time it's going to be a number and it's going to be raised to the x. So like 1/2 to the x power, 2 to the x power, 3 to the x power. That is why they're called exponential functions, is because literally the exponent is the x variable, okay? So we're going to talk a little bit about some vocabulary today, and then we're going to graph some, okay? So we talked a little bit about the exponential function, a function that is in the form of y equals b to the x. Y equals ab to the x. Usually it's b to the x. A, there might be another number in front, and we'll talk about that when we go to graph. There's exponential growth. And exponential growth is going to be, let's see. So exponential growth is a of t. T being the time. A being the initial amount. So A is the initial amount, okay? 1 plus R raised to the t. R being the rate, t being the time. And you guys, R plus 1 is called the growth factor. And that's, so when you go to do some of your vocabulary tonight, it's here. So you'll see some of it's in section 7.1. Okay. So this is the exponential growth equation. And what it means is it grows, okay? So your line is always going to be a curved line. In exponential, it's always curved, and it's either going to curve down or curve up, okay? And you can tell if it's growth or decay. Asymptote is a line that the exponential equation, I want to say approaches. It says approaches. That it wants to touch, right? It just kind of parallels and it almost touches it. So we'll really talk about that line and how to figure it out, okay? And then I already told you about the growth factor. And now, do you guys see, look at exponential decay. See how it's going down, decay? Now, there's some that are flipped, and you'll be able to tell if it's growth or decay. Again, you guys, we have a decay model. A of t equals the initial amount times the decay factor. 1 minus r is the decay factor, and it's raised to the t. So the difference between, you'll notice the only difference between decay and growth is that it's 1 minus r or 1 plus r. R is rate, t is time, and a is the initial amount. And a of t is what you have after that amount of time. So let me say that again. A of t is what you have after the amount of time. And you guys, remember, decay or growth, sometimes we think money, but it's not always money. Yes? Yes. Okay, so far so good? You guys, and I just want to make sure that you guys understand that decay doesn't have to be money. I mean, we think money, like we lost money, right? Or we made our money grow. It could be anything. It could be plants, you know. There's different things. I'm sure that some of you might have talked about growth and decay maybe in chemistry if you've taken chemistry. Or maybe physics as well. You guys are like, no. No. Okay. So I'm on the second half of the first page. So we have a couple things that we need. So this is called the parent function. Notice the number in front of B. If there's no number in front of B, then it's 1. And you need B to be greater than 1, okay? A can be any number, but B needs to be greater than 1. Let me say it again. A can be any number, but B has to be greater than 1. The type of graph, it's a continuous one-to-one increasing, so you can see it's increasing. You guys see how it's skirting, like it's approaching the x-axis? It doesn't touch it, but it's right along there. That would be our asymptote. Okay, domain, all real numbers, range is all positive real numbers. And we're going to talk about how the range changes. The domain, you guys, will always be the same, all real numbers, because you can plug anything in for x. It's your range that's going to be affected by how we move it, if we move it up or down, right or left. Okay, and then our y-intercept would be 0, 1 because of when you plug in 0 for an exponent, you get 1, okay? So let's go ahead and graph a type of a parent function, okay? So we're going to graph number 1. Well, this example. And the first thing that we're going to do, you guys, is we're just going to make a chart. So we're going to have x's and we're going to have y's. Now, you can pick any point. Because 4x and b is greater than that 4, I really want to pick, I'd like to pick -10. So we're just going to pick -10. And then let's pick -2, -1, 0, 1, and 2. Well, why did I pick the -10? Because I want to see how close it is, where it lies, okay? So you need a calculator because we're gonna do this in our calculator. We're gonna get some decimals so we know where to graph, okay? And we need to practice how we're going to put numbers and raise everything to a power. If you're using one of my calculators, you're gonna put the number -10 in, y to the x, and then 4. No, you do the opposite. You do 4yx -10. If you have one of, so I just want to make sure 4 raised to the -10th is like 0.000. So that's a good indication. Now we're going to do 4 to the -half. Okay, I mean not -half, 4 to the -2. So 4 to the -2. Did you guys get, what did you get?
I got 0.065.
Yep, that is correct. Then we're going to do 4 to the -1. .25. 4 to the 0 power. This is my favorite one. What's 4 to the 0 power? And we're going to do 4 to the first power, which is 4. And then we're going to do 4 to the second power, which is, okay. Can we go any further? We could keep going, but why should we stop at 2? The graph doesn't go any further, so we'll just have to estimate that. Okay, so now we're going to graph this. You guys, in first period, they asked me, how did I pick those numbers? I just picked them. You always should pick 0. You always should pick 1. 2 is always good. Stay within there. I picked -10 just so I know how far out I need to go. So you guys, -10 is close to 0. So we're just gonna put a point like really close to the x-axis, okay? I mean, it's so close. Then we're gonna do negative 2.625, so that's kind of here. Then 0.25. Then we're gonna go to 1. Then 1, 2, 3, 4, and then 16 is way up there. So we're gonna kind of come around. And that probably darted out a little more than I meant to. There we go, that's much better. People at home, I'm very, very sorry that that looks so horrible. We're just gonna wipe this out. Yep, put it on tape. Miss Flurry screwed up. Is that great? But it's okay. So now there's 3 things that we have to talk about. Okay, so tonight when you go to start your homework, there's 3 things you have to do. Graph it, domain, range. You probably need to talk about your asymptote, okay? So, domain. What did I tell you about your domain? It's always the same, which is X is all real numbers. Okay, so your domain is all real numbers. We literally picked any number, and we could keep going, you guys. Okay? Now, our range. Our range is never going to cross the y-axis. Okay? So that means that our range is y such that y is greater than 0. It's never going to be 0. And the reason that is because, see the line that it's skirting, like it's going right across the x-axis? That is y equals 0. And then our asymptote is either the x-axis or the line y equals 0, because those are the same. So again, domain is always going to be all real numbers because we can pick anything. Your range is going to really depend on what we add or subtract to it. And then our range and our asymptote are related, okay? So it's approaching the x-axis, which is y equals 0. That's how I got that. Our range is going to be, if you put in negative 20, you're going to get 0. You're never going to get a negative number, okay? And that's because 4 is positive. So that's part 1.